We're going to be talking about ionic bonding with common transition metals in polyatomic ions. So on the back side of your periodic table, there's this box in the upper left-hand corner that gives you a list of common ions that we're going to be using. This isn't an extensive list, it is just a cross-section of a larger list, but these are the most common of these elements, and this is just a set of polyatomic ions that we are most likely going to use and see in this class. So you'll always have this list available to you, and I'm going to start off by talking about the positive cations of the transition metals. So in previous videos we talked about the fact that transition metals can take on, and as you can see here, an example would be you have chromium that takes on a +2 and chromium that takes on a +3. They're designated with a Roman numeral. So whenever you see a transition metal with a Roman numeral after it, that tells you the charge of the ion. So this is a 2 because that's a 2. Copper 1, copper 2. If you don't see a number, it's because it's a 1. So iron can take on a +2, +3 charge. Iron can take on multiple charges besides that. It's just those are the two common ones that we're going to be working with. Okay, so I'm just going to show you a couple of examples of how to read and write transition metal ionic bonding. So I'll start off with the coppers, so copper 1 and copper 2. So those are my cations. So I have copper +1. It's my first example. And I'll pick any anion off my list over here. So let's just pick sulfur. Sulfur has a -2 charge, and in order to create the compound, I need to add on another copper with the +1, so I have +1 + 1 is +2, added to the -2 for sulfur. And because those charges cancel out to equal 0, I know that I can create the compound, and it took me 2 coppers to do that and 1 sulfur. So this is copper 1 sulfide. So when I name this, to denote that it's copper 1, I have to write it copper parentheses 1 close parentheses, and use Roman numerals, not numbers. So this is copper 1 sulfide. So the only difference in the naming is this Roman numeral right here. So what if I wanted to use copper 2? So copper has a +2 charge, and then I'm going to add it to sulfur again, and +2 - 2 cancel out, therefore it took 1 copper and 1 sulfur. So this compound is slightly different in the ratios. This is a 2-to-1 ratio, this is a 1-to-1 ratio, because this copper ion had a 2 charge. So this is copper 2 sulfide. So you can see the compounds are different because the charge of the cation. So the only thing that's different for transition metals is, number one, you have to look on this list because there's nothing on your periodic table that tells you the charge of these ions, and the fact that they can take on multiple ions, you would have to be told which ion it is going to take on. And then when you name them, you have to use Roman numerals. For the next set, polyatomic ions are also on this list right here. So there's one thing to note is that this right here is the only positive polyatomic ion. So you can see a polyatomic ion, poly means many, so many atoms that form ions. We'll talk about ammonium. NH4 + 1. We're going to talk about the structure of this molecule later. So just know for now that a polyatomic ion is when you have multiple elements together and as a group they have a either positive or negative charge, making them ions. So I'll show you a couple of examples on how to work with these. So let's pick ammonium. So ammonium is going to be my cation because it has a positive charge, and I'm going to write it exactly how I see it, NH4 + 1. This is subscript, this is superscript. I'll add it to, let's say, fluorine. So fluorine is my anion, it has a -1 charge. So automatically I see my +1 and my -1 cancel out, so that's all that matters. So I'm going to rewrite this whole ion exactly how I see it. You do not get to change anything about this. The only thing you're allowed to do is get rid of the charges. So this whole thing transfers over exactly how you see it, and because +1 and -1 cancel out, it's a 1-to-1 ratio. So there is 1 ammonium in the fluoride. So this is ammonium fluoride. So 1 ammonium to 1 fluorine, when you name it, you change the ending of the second element to "ide" exactly the same way you would do in regular ionic bonding. So there's really no difference here. It's just the way that you write these compounds. This whole molecule has to go as one unit. You don't get to change that number 4. Okay. So what about when it's a negative anion? So there's an entire list here. So let's just pick one. Let's pick carbonate. So carbonate is CO3. That means there's 1 carbon, 3 oxygens, and the whole compound has a -2 charge. So let's say that we're going to take sodium with a +1, carbonate with a -2 charge. So automatically I see these charges don't cancel out, so I'm going to add on another sodium. +1 and +1 is +2. That carbonate has a -2 charge, that equals 0, so that's good. So my compound is a ratio of 2 sodiums and this 1 carbonate molecule. So I'm going to write it exactly how I see it, but without that charge. So this is sodium, name the first element as is. And the thing about polyatomic ions is they get to keep their names. So because this is carbonate, you call it carbonate. So you don't change the name at all. Let's do one more example. Let's do sulfite. So SO3 2- or -2. Let's bond that with, let's say, aluminum. So aluminum has a +3 charge. Sulfite is SO3 -2. So this is a situation where my 3 and 2 don't cancel out, so we get to the least common multiple of 6. So I'm going to add on another aluminum and then add on my anion until I get to 6. So +3 + 3 is +6. -2, -2, -2 is -6. Those cancel out. The ratio is that it took 2 aluminums and 3 of these molecules sulfite. So here's the trick. Because there are multiple, if I wrote it like this, it looks like I have 33 oxygens. That's not true. You have to use parentheses when you have multiple of a polyatomic ion. So because there are 3 sulfites, I put sulfite in parentheses. Just the polyatomic ion goes in parentheses. And then you put the number of how many there are on the outside of the parentheses, so it doesn't look like you have 33 oxygens. So this tells me that I have 3 sulfites. Well, as I would name this, so aluminum gets to keep its name. Aluminum. And SO3 gets to keep its name, sulfite. And that's it.